Hello, good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's session. Really pleased to be here with you today as we get ready to dive in to registers, and we're also going to be going through custom variables with you today. So today we're going to give you a solid understanding of registers and custom variables, how to use them inside your models, learn how to use interactive registers and custom variables, master the different Maths.JS functions, and there's a lot of them, and show how you can use these inside your game logic. As always, my name is Matthew. I'm the evangelist for Machinations, and alongside me is the true legend that is Cesar, our master diagram craftsman. Say hello, Cesar.
Hello, everyone. I hope you find today's session useful again. I don't know how many are here that have also attended the 101 last week. And as always, if you have any questions, please don't hesitate to ask. We will try to answer them as we go through.
Please do subscribe to the channel to get notified every time we add new content. All of the models that we've created today are also going to be published to the community, and we'll post the link to them at the end of today's session so that you can have a look. And I'm going to hand over to Cesar, who's, I think, going to be sharing the first model.
So as the title said, we will be talking about registers today. This will be in our first part. After that, we will be transitioning to global variables, custom variables. For those of you that have attended the 101 last week, you may remember that we went through all of the nodes here, explaining what they do, how you can use them, how to implement them, and things like that. But we only briefly discussed registers, claiming that it is a very complex and powerful node, and you would need to dive deeper into detail when speaking about registers. So today's session is just about that. If you remember last time's models, they were quite heavy. We had two of them. This is the only model that we will be using for registers. I'm going to be walking through most of the functions that you can use inside them, how you can implement them, and in what cases they might be useful or not. Before that, keep in mind that what I'm about to show and the examples that I'm about to show are not the are not the only way in which you can implement those mechanics. So there are, I would think that for every mechanic that you can think of, there are at least 10 different ways that you can implement them in Machinations, and there is no one correct method and one wrong method. And as long as they work, they are correct in my book. So do not, if there are people here that have built some things and I'm going to show the same mechanic that they have built, but in a different way, it doesn't mean that they're wrong and I'm right. Both are correct as long as they function as you want them to function. But moving on, and Matthew, I will ask you to interrupt me at any point if there are questions that I need to address, because it will be a bit of a monologue here. We will be going through the different functions that registers have. You see that I have them categorized at the top here. And as I said, I'm going to try and provide some examples for them. It shouldn't be too difficult. For those of you that have not attended the 101 session, please don't think that this is, oh, I'm going to not understand anything. I really need to watch that. While I do advise that you watch them in order, it doesn't mean that you will not understand what we are about to present here. This is pretty much a standalone session, just focusing on registers and their applications. So moving on from that, I'm going to start just explaining them one by one. We have arithmetic functions. The simple way to implement registers, as you saw last time, is when you add one to the canvas, you have a pool. You can connect that pool to a register. It will have a variable name on it. It will automatically default to a name, but you can switch it to whatever you want. In my case, I have two pools here on the left, one with a value of 4, one with a value of 5, and I am sending the top pool with 4 as the variable a inside each of the registers here. So I can use one pool to send information into multiple registers with the same name. So it doesn't matter because they are in different registers. And I'm using the bottom pool of 5 to send the value of b inside of all of these registers. Now, by looking at the registers here, you can see that while the execution is not happening, there is an fx symbol in here. We don't have any numbers. They don't do any calculations if the simulation is not running. But should we execute a step in the simulations, they will already start performing calculations. Now, I'm going to talk about the functions that we have here. They should be pretty self-explanatory. We have add, which basically adds the two numbers. You can see in the example here that we don't necessarily have to use variables. We can use numbers as well. So in here we have add 4 and a. So we're doing basically 4 plus a being 4, the result is 8. I can change this to having it as b, for instance, and then it's going to change to 9. And as I mentioned, add BA is the same as writing A plus B. So there is no difference between these two functions. If you want to implement them, it's up to you. If you want to put add, it's up to you. If you want to put A plus B as just an operation. Now, the advantage and disadvantage, at least in my experience with doing add versus doing symbols, is that if I have a sum of, let's say, 30 different elements, putting a plus between each one of them is a bit tiring. So I rather do add and just add the letters between them separated by commas. I find it easier. Whichever method you want to select is correct anyway. So pick your own method. Subtract is a subtraction between A and B. So again, because we have 4 and 5, the result should be -1, so it can go negative. Obviously, we can have negatives, we can have decimals. Registers are able to handle that. Since those aren't resources that are actually stored in the similar fashion that pools do, those are resources that are later used for different calculations. Via state connections, you can send them as information. We have multiply, which multiplies the two values of 4 and 5 to a 20. We have divide, so this is where we get the float number, right? We divide 4 by 5. And we have power, so we raise a, which is 4, to the power of 5, and it gives us 1024. For cases like this, where you have 1.02k, if you want to go granular and see the result, when you click on the register, in the top part here, you can see in the right side of the formula, there's an equal and the actual value that is presented. If you hover over it, you can see that it even shows the value 1024. So those are basic arithmetic functions. It's, well, I don't think I need to explain what they are used for. They are very common. You will use them as smaller parts of larger formulas, probably in some mechanics that you have. Moving forward, we have some other. So in here we have absolute, which returns the positive. It's the absolute value of the number. So b minus a would be 5 minus 17 would be minus 12, but because it's absolute, it's 12. So it's the absolute value. Ceiling. So the next 3 ones, or the next 4 ones, I would say, ceiling, floor, fix, and round, they are always about rounding the number, but they do so with different logics. So a divided by b is going to be 3.4. And because it's 3.4, you can only round them towards 3 or towards 4. Ceiling will round towards the higher integer. Floor will always round towards the lower integer. So those two are from approximation. Round will always round toward the nearest integer. So in our case, because it's 3.4, it's going to round towards 3. And fix, it's always going to round towards 0. So again, because we have 3.4, it will round towards 0. It's going to be 3. And at the end, we have modulus, which again is what is left after we divide 17 by 5. We are left with a 2 as the modulus. So all of these, again, they will generally be used as parts of larger formulas. For me, I end up using floor and round a lot, maybe even ceiling, because there are a lot of cases in which you want to round numbers towards integers. That is because resource connections and the concept of resources, usually when being transferred between pools or through converters, they cannot interpret fractional values. You cannot transfer half of a resource. You have to transfer one resource, right? So that's why, in order to avoid certain issues that may appear, sometimes you need to round the number that you get from a formula. And because of that, I find myself using floor and round, especially, quite a lot in these types of situations, because there are a lot of calculations that will give float numbers. Moving on, we have some power functions, right? We have square, cube, square root, and sine. Those show, so square, cube, and square root are pretty self-explanatory. Sine it basically returns 1 if the number is positive, -1 is if the number is negative, and 0 if it's 0. Because I have sine of -a in here and a is positive, the sign is going to be negative. So this is like a Boolean type of function, almost Boolean, true, false kind of function. We have logarithms as well. In the past, I believe that when I first presented the 102 session, I might have claimed that I don't really use the logarithmic functions. That has changed in the meantime. So it appears that there are certain games that use calculations that are based off logarithmic values. And I found myself using them more and more lately. Logarithms are pretty easy to implement. You can do with 2 values, log a, b, and then you have the classic logarithm of 10 and 2 and just log of a. So those are for the logarithmic value. Now, final ones in the arithmetic, we have lowest common multiple, greatest common divisor between 15 and 5. Lowest common multiple will be 15 and greatest common divisor will be 5. I don't think those need explaining. They are particularly useful when you have, I would say, 10 different numbers, not just 2, and then those functions can really shine. But after all of these, I will be trying, as I said, to give an example for, I'm not going to give an example for each one of them, but at least one arithmetic function, I will try to give an example of how to use it and implement it.
There's a question in the chat, Cesar. Yeah. Have you ever come across someone that's been able to use a log function in their game design?
Log function?
Yeah.
Yes, that would be me.
Oh,
but
really?
not just. Yeah, no, there are games. So let me, okay, so I have used log for a particular example that comes to mind is I was looking at a game. It was an idle game. And being an idle game, you have buildings that you build and each level becomes more expensive, right? And it produces more, but it becomes more expensive. And I found myself needing to calculate, say a building costs 10 and then it would cost 11, 12, 13, and you have 100 coins. So you can technically upgrade multiple levels at once, right? I would need to update that cost in real time and do it all in a single step. So I needed kind of a fancy formula that could predict the future for me and tell me how many levels am I able to upgrade my building with the current coins that I have. And it turns out you need logarithms for that. So I will not claim that I have found the formula. I found it online, but it was still a great use for it. So yes, you might need them. And that formula has proven to be very, very powerful and helped me a lot because I was able to not only determine how many upgrades can I do with the coins that I have, I can also determine what's the total cost of those upgrades, right? So I could bulk upgrade, which was a tremendous help for me personally. So I would say I don't use them a lot, but when they are actually useful, they can save your life. So yeah. Moving on to the example is a bit simpler than what I have described. We have an experience converting to level situation here, right? Our player gathers experience, they level up at certain thresholds, and the level is the one determining what the cost of the next level will be, right? So I'm going to run it step by step. We're going to get random experience between 301 and 500 every step. Our cost is starting at 1,000. This is a exponential curve, a very soft exponential experience curve. You might see this type of curve in a lot of games. I certainly see it in a lot of games. It is the exponent, the base here, 1.15, that differs usually, but depending on how soft or steep you want the curve to be, this is kind of a generic experience curve. So we start at 1.15k, so 1,150 at level 1. We will reach that in just a few steps. There we go. So now that we have enough experience, we're going to convert it into a level. Level 2, the level up cost goes up. It's now 1,322.5. And now this is something important here. So because we have a 0.5, we might have problems here. This is why in these types of formulas, so I'm going to hit step. See, we tried to convert, but we weren't able to. So when a situation like this happens, it's because the converter is expecting to get 1,322.49999. You can see on the top right there, it's expecting to get those many resources, but instead only gets 1322 because we cannot transfer decimals, right? And then it's confused and it cannot convert, and it's sad times. So in order to prevent that, what we're going to do is we're going to take this formula and encompass it inside of a floor function. That way, I will round towards the lower integer. It doesn't matter. I could use round if I wanted to. And this way, we make sure that we are able to convert every time, right? So now, when I will convert to the first level, my cost is a fixed 1322, and my converter will no longer be confused, and it will be able to convert properly. Now, the sacrifice that you have to make is that you're going to waste 0.5 experience, which in the grand scheme of things with thousands of experience getting converted, I say is a fair compromise, and I wouldn't worry about it. But this would be my approach, just to, and this is a perfect example for where you need to actually approximate the number towards an integer. That would be a fairly straightforward example for an experience curve. If I left it running, it's obviously going to increase the level and the costs and so on until the cost becomes super high. Such is the nature of exponential curve. Are there any questions, Matthew, so far that we have, like general ones that we should address? Okay.
You're good so far. It's a great explanation.
Thank you. Now I'm going to be moving on to bitwise functions. By the way, as I explained this, I'm glad that someone asked if I have ever used logarithmic functions. I encourage you to keep asking this, because for some of these, I'm going to give you that answer before you ask me. So I'm going to tell you straight up, I never use bitwise functions, but I do know that they exist. I do know that they can be used. They can also be used through other means. So the bitwise functions, since I come from a programming background and I am quite knowledgeable of binary and things like that, they are easier for me to understand, but they are not necessarily intuitive, and they are not the only way in which you can implement their own logic. So to understand bitwise functions, we should understand binary values. It's a number written in binary is basically only written with powers of 2 in mind. I'm not going to go into detail and turn into a professor here or anything, but just understand that there is 17 is represented as 10,001 and 5 is represented as 101 in binary. So when we are operating on binary, we are operating on the bits of the numbers, basically. Using the examples of 17 and 5, I'm sorry, I'm just going to go through quite briefly through them because, as I said, not very useful. We have an AND on bits, we have an OR, we have a XOR, left shift, right shift. So those are basically shifting bits between them, and right log shift. So just know that you can operate on bits. There may be a case somewhere in the world where someone has used them and they are very useful. I don't know. Maybe they are like logarithms. You don't know you need them until you need them. And when you need them, you need them badly. But at the moment, as I haven't found that use personally, I'm not going to insist on them too much. Just know that they are a possibility. Moving on to logical functions. So those logical functions are useful. Those are very useful, and I use them a lot. They can be used in other forms as well, is why I don't use the exact semantics that we have in here, the exact syntax that is in here. But they are very, very powerful, and I use them quite a lot in my models. We have, so in logical mathematics, you know that 1 is considered to be true and 0 is considered to be false. So basically, when you are checking for something, you are checking whether it's true or false. It's like a binary selection. In here, we have 7 and 4 as the two numbers that are sent. And for AND, OR, and XOR, and NOT, they are basically looking at, well, since we only have numbers in here, they are basically looking at if they have a value that is 0 or not in this case, right? Since both numbers are not 0, you can see that all of these are, so and or are true, so it's not, and not, which is the opposite, is also false. If I were to turn A into 0, then everything shifts around and becomes 0 because the top one is 0. On the OR, we have a 1 because at least one of them is not 0, so the OR is true. XOR, which is true when they are opposites, so one is 0 and one is not, becomes true, and not A, which is the opposite of A, becomes 1. Honestly, out of these, and OR are super, super useful, so you will be using them a lot. You can implement them in other ways as well, as I said, but you will be using them a lot. XOR and NOT, I haven't really found much use for them yet, but again, there may be cases. And since there aren't a lot of logical functions, we can jump straight into an example here. This is a very simple example where you have a door and you need 2 different keys to open it, right? So we have find blue key and find yellow key. Each of them have a 20% chance. You can think of those as the player roaming around the map to search for the keys. And in order to open the door and complete the level, so we have a condition here, the player searches for the 2 keys. So they found the blue key because I have an AND in here and I need both of them. It's a 20% chance. Now they found the yellow key. Because of that, the AND turned to a 1. We got the condition, we open the door, the level is complete. So this is one very, very basic example, but where you can use this. But you can imagine that there are a lot of different conditions when you need different things to happen and all be true at the same time. And for that, you're probably going to use an AND function. Okay. If there are no questions, Matthew, I will be...
You're still good. Please carry on.
I will be moving on to matrix. Now, matrix functions, those are something that I discovered, I think, 1 year after working with Machinations. So I've lived 1 year without knowing they existed, and I would have needed them sooner. So I was very happy when I found that those functions exist. But to first understand matrix functions, because the functions themselves are very basic, we must first know that inside Machinations, it is possible to implement arrays. So when I write a list of numbers separated by a comma between square brackets, it's going to form an array of values, right? And I can use a system like this, where I continuously send resources. So if I were to hit step, you can see that because B is 1, I am reading the first value in the array, which is 6. If I send another resource, I'm reading the second one, which is 3. So basically, I can get to decide which value I want to read inside of the array. But this is a simple way to implement arrays, right? Keep in mind, they don't necessarily have to be implemented like with just giving them numbers directly. You can have them as variables, as we have in here. We have 3 different pools. They send A, B, and C. We have A, B, and C in here. And it will still form the array, and we are able to read it in the same way. So this is obviously useful if at some point in the executions you will be changing those values. That means that you will automatically change the values in the array, you will automatically change the values that you read, and so on and so forth. Now, I'm going to go through something else first, which is even more recently than what I said previously. This is like 3 months ago. I discovered that you can also use matrices inside Machination. And the way in which you implement those is you basically implement arrays as element of an array, if it makes sense, right? So in here, I have my array of 1, 2, 3, 4, which is an element of a bigger array, and separated by comma, I have another one of 5, 6, 7, 8, the second element of the bigger array. And when I read it as A, 1, and 2, 1 will represent the first block of elements that I'm reading, and 2 will represent the second element of that block. So in this case, my value should be 2, if I understand correctly. And if I were to switch this to A, 2 and 2, I'm going to read the second element from the second block, so that will become a tick. This is a simple way to implement matrices inside Machinations. Those, by the way, I would say matrices I haven't implemented quite often, but arrays I implement quite a lot, and they are very, very useful, especially if, for instance, in the case of levels, right? You may have a formulaic approach like this, or you may have a list of thresholds that are defined not by a formula, but just static values. And if you want to do 150 levels, trust me, you're going to use an array for that, because otherwise you're going to go crazy. So arrays are very powerful for that. But to talk about the actual functions of matrices, there are only two of them. Pretty straightforward. One is called size, one is called sort. Now, when I hit step, size tells me the length of the array, right? So I have 4 elements, so the size is 4. And sort will sort it for me. If I zoom in here, you're going to see that it sorted them in the correct order, ascending. So those are the only two functions that we know of and we have used. Both can be useful in their own cases. I have found myself using sort when I try to determine, there are times when you need to determine what is the highest values in your array. So to do that, you can sort and just take the last element out of that one. And that's one way to do it correctly.
Is there any way to do, rather than doing sort ascending, is there any way to do sort descending?
Yes, you can do sort descending, but honestly, so the sort function, okay, this comes into how you use Machinations, right? So I'm doing sort here and I'm sorting ascending. Now, this is always going to be the same, but what I can change is the way in which I read the array, right? Because right now, if I hit resume, actually, because this is actually the build when I read descending. So in the way that I built it here, you can see that I'm sending 4 resources in and I'm decreasing 1 every step, which means that I'm starting from the 4th slot and moving backwards, right? So if I hit step here, even though the array is sorted ascending, you can see that I am reading it the other way around. So I'm starting with 9, 6, 3, and 2. And obviously, if I go for the classic approach of only pushing 1 resource, it's going to read it ascending. So the sort function always does the same thing, but the way in which you read the array is up to you. So you can do both.
Okay, thank you, Cesar.
And the example that I want to show with arrays. So this is basically, well, a lot of games, mostly mobile games, mostly live service games, they have these recurring events, right? They have periods of events. 1 week you have an event, the next week you have another one, the next week you have another one, maybe the first one comes back and things like that. I am using an array here to list the order of my events, and I am using the different days to set up which event is active in which day. So if I were to hit play right now, because as I'm simply reading my array, you can see that the pools here turn on and off, which kind of signal which event is active in the current day, right? So I am rotating between event 1 and 2, 1 and 3, 1 and 4. And based on which event is active, I can further use this pool to activate a bunch of different actions in my model. You know, maybe in the first event, you get the blue coins, in the second event, you get yellow coins and things like that. We can all imagine from here. So this is a simple way to just implement those types of event changes in your game. But obviously, there are way more applications to it than just that. Moving on, we don't have that much left. Moving on to probability functions. So probability functions, we have factorial, random, and random int. Factorial is, well, it's a mathematical function, not much to talk about. But random and random int are very interesting functions, and you're gonna use them because sometimes you want values that are between a minimum and a maximum. In our case, it's going to be 4 and 7, and you don't know what value you want to pick. You just want to try values out. Random picks a value between 4 and 7 with decimals as well, so it's not a fixed number, right? It's not an integer. While random int picks a random integer between 4 and 7. Now, important mentions here. One would be for random int, it is possible for it to pick the lowest number, but it is not possible to pick the highest number. So random int between 4 and 7 will pick between 4 and 6. So always remember that. And the second mention is, if I were to hit resume right now, the random that is selected at the beginning of the execution stays the same throughout the entire execution unless the register receives an update. If you want to avoid that, by clicking on the register, you have a property here, which is force update value each step. If I tick this, it's going to start changing its value at every step. So now you can get a different result. Depending on what you're looking for, you may want the value to stay constant throughout the execution, or you might want it to change every step. Both are possible if you use the property here.
Quick question there. Is it possible to use random int AB plus 1 inside the brackets as a valid function?
Yes. Oh, yes. That's actually how I would approach it. So when I want to read it, so let's say I have two values which are fixed and I want to pick a random between them, I'm always going to type it exactly like this, random int between a and b plus 1, because that way I know it can pick 7 as well. So if I hit force value at some point, it will pick 7 as well, but it will never pick 8. So yeah, that's not only it's possible, it's also optimal to do so. So yeah. All right. For arrays, it works as well. We have pick random, which picks a random element from the array. Again, it's the same rule as random, the other randoms. You can select it to force update value or not. So it's the same idea here. And the examples that we have for randomness. So you can imagine randomness can have a lot of different applications because there is a lot of randomness in games. There are a lot of chances. The examples that we have in here are a basic hit versus miss mechanic. We have a register on the top, which is random int between 1 and 100. We have a hit chance of 0%, a miss chance of 100%. And if I hit step, we are using the value that we get in the random int to decrease 1% out of the 100% and increase 1% for the 0. So you can see the hit becomes 7% and the miss becomes 93%. So, and most of the times we're going to miss. If I set this to also force update, it's going to change the hit chance at every step. So sometimes we get hits in, sometimes we'll miss. It depends. For the interactive register, since registers have the property of interactive, you can see that it's not about a formula anymore, it's about a number. We have an initial value of 15 here. It's the same principle as above, as in adding to hit and removing from miss. The difference with interactive ones is that you can interact them during the execution. So if I click on it, you can see that I increase it, I can decrease it. So I can adjust them while the execution is running if I so desire. Keep in mind that when you reset, it's going to default back to the initial value. All right, so those are probability functions. They aren't a lot, but again, super powerful, and I use them quite a lot for a lot of different mechanics. Then we have relational functions. Again, super useful, again, for conditions. They are similar to the logical ones with and or. The relational as well are kind of useful for the same reason. You want to check for certain conditions and based on these conditions, apply certain mechanics, make certain mechanics available, make certain events available, things like that. So for that, relational functions are great. Basic ones, we have compare, equal, and unequal. Compare returns the result of 1 if the first element is larger than the second, -1 if the second one is larger than the first, and 0 if they are equal. Equal only checks if the two elements are equal and returns the 1, and the 0 if they are not, and unequal is the opposite of equal. So when one is 0, the other one should be 1, and the other way around. Then we have the again, comparison ones, larger equal, smaller equal. So again, those check between the elements and check if one is larger than the other. They can return either 1 or a 0 based on whether that is true or false. So you might be using this a lot for comparisons of different things between certain parameters in your model. You may even check this, for instance, to see if you have enough money to make a purchase, right? You can check the number of available money that the player has with the cost of whatever it is they are trying to purchase, and only when it is larger are they allowed to make that purchase, for instance. But as an example, what I have here is a small, let's call it upgrade mechanic for an item. So our player is slaying enemies, right? And they are gathering materials. And they also have a number of lives. There is a 30% chance they will get the material when they slay an enemy, and there is a 5% chance they will lose a life. If they have managed to collect 5 materials before they lose all their lives, right, which we are checking for in here, we are checking both lives and materials. If they are able to fulfill both conditions, then they get to upgrade their item successfully. So because this is a multiplication between the two, it means that both conditions need to be true, because if one of them is 0, the entire product will be 0, right? So because we are here, B is larger than 5, A is larger than 0, we have our materials, we have our lives, we can upgrade, so we did upgrade. And it's a pretty basic example of just two conditions that form an AND condition for our player. Moving on to statistics. Those can be useful for a number of reasons. We have an array up here with a bunch of elements, and we have a lot of statistical functions such as maximum, minimum, median, mean, sum, product, and standard deviation. Do not ask me what this means. I have no idea, but it exists and you can use it, and maybe someone more knowledgeable than me knows what it means, but yeah, I have no idea. But max, mean, those two super useful. Mean as well, I use them a lot. We actually have an example where I show how to use them. So let's move on to that. This is how I would use minimum. So do not be scared by the large number of state connections. This is no big deal. In the top here, you see I have represented 3 players and their ability cooldowns. Each time they use an ability, they will generate a cooldown. You can see it on the labels on the resource connections, and they have cooldowns until they can use their ability again. So when I hit step, I have cooldowns of 700, which can mean whatever I want, 500 and 900. I am looking at the minimum because I could technically decrease every pool by 100 every step, but I would have to wait 5 steps if I were to do that, versus just calculating the minimum and deducting that from every single pool. So now I have my cooldown at 0 for one player. The minimum is 0. I'm going to need to replenish the cooldown because they just used the ability, so they will replenish the cooldown. Now, which player is next in line? Player 1 has a cooldown of 200, so they're going to use their ability. They get to 0, they replenish their cooldown, and so on. So by doing that, instead of waiting step by steps for players to get to 0, I can identify the minimum value and skip a few steps where players would do nothing anyway because they are waiting on cooldowns. And we're almost at the end. We have trigonometric functions. Those, similar to the bitwise, I have never used them. Now, they might be useful. I am sure there is some funky stuff you can do with some of these functions. I have never used them. I have no idea. I never liked trigonometry. Even in school, I didn't like it. So I try to avoid it as much as I can. But they exist. You can use sin, cos, tan, cotangent, and all of these. They are functional, and you can use them. I don't have an example for it because, as I said, I don't really use them that much. And the final one is utils function. Those are pretty basic. Those are kind of like text, right? Is integer, is positive, is negative. They return 0 or 1 based on whether these numbers are meet the condition stated in the function itself, right? Is prime, is 0, and so on and so forth. So those are pretty straightforward. I don't really use them because you can use them in other forms, right? You can do larger a 0 instead of is positive. You can check if a number is an integer in other ways as well, is negative as well. So yeah. But as an example that we have here, for instance, if I were to use is positive, I would use it to compare the two pools here. The example that we have here is an example of rubber banding in racing, where if the player is ahead, the AI gets better and better so that the race remains exciting. And again, if the AI is ahead, the player gets certain advantages, so they can catch up to the AI, and the race remains excited and disputed until the end. I have two cars here. They both get P50 distance, so between 1 and 50. So they can put some distance between one another. And by checking on whether one of them is ahead or the other with is positive, you can see that I'm turning these connections on and off, which is the advantage that I'm giving to the player through rubber banding. So I am sending an advantage of extra 10 distance to the player that is behind at all times. And this ensures that they always kind of stay close because of that advantage. You can see those toggle left and right quite often. So they are pretty close to each other at all times. And that would be the last example of the register part. And I think we can move to the custom variable part, Matthew, unless there's something else.
We're going to do a quick example of where we're actually using these registers.
Oh, yeah,
so
sure.
Here I've created a very simple little system that just kind of shows how we can actually implement registers. Really simple little game simulation. The red little counter is my player. Let me slow it down a little bit so you can see what's going on. As my player goes round, there's certain things that the player has to do in order to play the game. The first one is find ingredients. Once they've found ingredients, I've got a crafting system where they go through, they find the ingredients. Once they have enough ingredients, they are then going to craft them. Once they've crafted the item or enough items, they can go and they can complete the mission. What I'm going to use my registers for is, I think in a lot of sessions where we've looked at kind of using converters, here, rather than having a kind of a linear approach to the cost of each crafting cycle, here I've got some fixed values. So I'm sending these in as an array into here. So depending on how many items the player has crafted, that's how many items are going to be required to before the converter in order to craft the next set of items. And it jumps up from 1 to 2 to 9 and so on. It's a great way of kind of if you've got a specific values that you're using inside your game rather than a formulaic approach, that's a great way of doing it. I'm also using a condition here so that only when the player has enough ingredients, so I'm sending this ingredients in as the variable A, then I'm doing a lookup into the array lookup to say, based on how many items the player already has, does the player have enough ingredients in order to do the next set of crafting? Then I'm using that as a condition to say, only make the craft items option available if the player has enough ingredients. One more example, just really quickly. Here we've got a register, and I'm doing a lookup to say what the player has to do in order to complete the mission. So I'm looking at equals which mission the player is on at the moment. So they're on mission number 3. And then if the mission equals 3 plus a second variable of larger items than 4, and then I'm multiplying that by 5 to say, right, this is now going to give me an output of the number 5. This is just a quick example where you can really get quite complex with registers, combining multiple conditions together, even multiplying those conditions together to create specific outputs. Great example of this is the Hades webinar we did a little while ago, where Cesar created some very, very, very complex registers, which had all sorts of different outputs depending on where the player was in their progression inside the game. Now we're going to switch over and we're going to have a quick look at our custom variables. And I'm going to let you share your screen, Cesar.
Yes.
Gaussian distribution, that's what we've got coming up right now.
Yeah, I saw it in the chat, so I said, okay, I'm gonna shut up because it's coming up. It's fine. We're talking about it. Right. So custom variables, those are a newer addition to the tool. You can find them in the bar on the left. We have custom variables. When you click on it, it's going to open up a list of all of the variables that you have defined. Obviously, we have prepared for the webinar, so we have quite a few in here. But yeah, I'm going to talk through the different types of variables that you can use, walk you through them, and see how we can use them. It's way easier than registers. Trust me, it's way more intuitive. So this one should be easy. So first off, we have a randomness type of variable. You can see that I have a simple torus pool drain mechanic in here with a variable of dice. If I were to search, so if I have 100 variables in here, I can just search dice. I'm going to find my variable. We have a randomness interval variable, which is set from 1 to 10. And that means that when I click on it, I can open up the details. It's the name, it's the type, which is interval. We have more of these. And it's from 1 to 10, uniform distribution, update on each step. So it's going to update this value every time. It has a uniform distribution, and it's random between 1 and 10. So it's just throwing a 10-sided dice, basically. So when I throw it, you can see that I get different results every time. And yeah, it's like throwing a dice, basically. It's equivalent to a D10 for those of you that have watched the 101 webinar on the resource connection. Now, to address the Gaussian question and uniform and Gaussian. So we have dice, which is the same variable from above, which has a uniform distribution. And we also should have a Gaussian in here. There we go, on the top. Yep, randomness. It's a Gaussian. It's the same idea, 1 in 10, but it has a Gaussian distribution instead of interval. Now you can see that based on the number that we get, we're going to have our sources fire a resource at the top. So this one will fire when we get 1 resource, the second one will fire for 2, for 3, and so on. Same for the Gaussian, just so we can track how many of them are we getting. And you're going to see that the Gaussian distribution is going to get crowded in the middle side, while the uniform one is going to just indiscriminately send them all over the place. So you can already see that the Gaussian has that bell curve, while the uniform is, well, all over the place, as I said. So this is the way in which we have them. Previously, we could do Gaussian. It was a giant pain to do it, but it could be done by using formulas and registers. But now that we have custom variables, we don't even bother with it anymore, because we can just use the custom variable and set that as a Gaussian, and then we can set the values in there. So that's it for randomness. We can use it as a fixed number. So if I have cost in here, and cost will probably be somewhere like 2000. So I have cost. It's a formula of 2000. It updates each step or play. It doesn't matter because it doesn't update. It's a fixed formula of 2000. It's just a number. You may say, why do it like that instead of just typing 2000 on the resource connection? Well, if there are those of you here that have built large models where you would have this cost in 50 different places, you would know that if for some reason you want to change that cost, going and changing it in all 50 different places is not pleasant. That way, if you have a variable named cost where you put the cost, you just need to change the cost inside of the variable, and then it will automatically, obviously, change it in all of those 50 places mentioned earlier, which is a lot more intuitive than just going and switching them manually. So this is a big boost to comfort, I would say. So for me, this was super exciting. But now Matthew has a model that can actually illustrate that.
Thank you, Cesar. A little while ago, we went through and we were talking about, I think it was a Web3 economy we were looking at. We built this model. And one of the things that we had with this model is we had one pool, which was our persona pool. And this enabled us to adjust which persona was running. And this persona was linked to all sorts of areas all over the canvas. And it made it quite complicated to follow all of these tracks, all of the state connections to understand which persona we were looking at. The beauty of the custom variables is here I've got a maths expression, and this is my persona. So I've created this custom variable called persona. I've given it a description so I know what it's being used for. So anybody coming to read it, say, right, select a persona, and then we have the formula that we're using. So now, rather than having these state connections all over the place, I can get rid of these, jump into my register, add that persona variable inside those registers. And that way, I only have to make that change once, inside the custom variable. I can delete these, and I don't need them anymore. So I can adjust everywhere where they're used just by updating them inside the custom variable, just to make life much easier, much more streamlined. To that example that Cesar was talking about, here I've got breed cost all over the place. It's used in lots and lots of different registers. If I had to go through and update this every time I wanted to test out a different value, it would be very, very time consuming for me to do. But again, just by adding in that breed cost directly into the formulas, then adjusting it here will adjust it in all of those different registers. So I can really quickly iterate on this and test different values to see what impact adjusting the breeding cost inside this game would have. Really streamlining my processes and making it much easier to manage these large complex models where you're using these same values again and again. Back to you, Cesar. I think you've got some more custom variable examples.
Yeah, I like this tag team that we're playing here. Yeah, we have a few more, not as many. They are pretty straightforward. We have them as a matrix number. So if we're going to look at the array math expression that we have, again, it's a math expression. It's an array of values. It has a formula. In the formula, I've written the array. You would implement it as you would implement it in a register that we just showed earlier. It's a bunch of numbers separated by commas between square brackets, right? And again, you can use that as an array later instead of having you would see if you ever had a register with a lot of components as an array, you would see that the formula spans on your entire screen. It's going to be like this big. If you want to keep it tidy, you can use an array and it will act as the register would. So if I want to read the index, I'm reading the first element, which is 10. I'm going to read the second, which is 20. So again, it works as a simple array. Important to note is that you don't even need a register for it. So global variables, earlier on, we explained how variables that come from, in the 101, sorry, we explained how variables that come from registers cannot be interpreted by resource connection. So if a resource connection sees a variable of A, it doesn't interpret it, it doesn't know what it means, and it does nothing. But resource connections can interpret custom variables, which is super useful because now we don't even need that extra register in here. We can just put the element that we want. So we have array, which is the same array that we're using here. We have a variable of lookup, which should be somewhere. There we go, which is 6. So it's fixed. Now we are going to look at the 6th element of the array by just typing array with lookup between brackets on the resource connection directly. So that's going to send 43 resources as that's the element in the array. Next, we're going to talk about external JSON. So those are new, exciting, and well, in a initial state, I would say we are working on improving on them. But what it actually means is that you can now use a JSON file. So I'm going to look at the spawn rate. It's an external JSON variable. I have a URL here for my JSON, which I'm actually going to show. It's public. It's for Pokemon. You have a bunch of Pokemon in here with a lot of information about them. And I am looking at the path value where I give the value of Pokemon 1, which, because we're starting the count from 0, is the second ID Pokemon, Ivysaur. And I am looking at the parameter of average spawns. So as we see in here, we have an average spawns of 4.2. So by looking at, by giving it that specific path value, you can see that the value here is 4.2. When I hit play, it's going to act as 4.2, and it can act as spawn rate. You can use it however you want, but this is how you obtain a variable from a JSON. And obviously, if you change the JSON file, you can refresh by using the button to refresh here, and it's going to refresh the value for you. Same with market feeds. Those are very useful for those of you that dabbled in Web3 economies, things like that. So if you want to check the prices of different currencies, I have just as a small example here, I have Ethereum called ETH. I am looking at the market. I am looking at the last price. If you can see it's 13.39. If I were to update it, it's going to update it. It's probably going to update almost every time I click here because the price is constantly changing. And I can save the value, and it's just acting as the value of Ethereum on the market. And the last example that I will present is a bit of a more complex one. We have the values of market feeds, and inside, again, this is more interesting for those of you that dabble in Web3 economies, but the logic of a market maker is interesting in more aspects, I would say, because it shows kind of an understanding of exchanges. We have a market maker in here. We have 1,000 tokens and $1,000. What I'm doing is that I am generating tokens at each step. So this equates to selling them. So I am looking at how many dollars do I need to remove from my liquidity pools in order for the constant to be the same, and how that affects my price. Keep in mind, one important thing that I need to mention here is that I am using the dice that I was using previously when we started the presentation. And one important thing to note here, that even if the dice is a random between 1 and 10, it means that if you have multiple dices, so you can see that I have dice on the connection and dice here, the two dice values are actually the same, right? So even if it generates randomly, if it generates as 6 in a step, all instances of dice in your diagram will have the value of 6. So it's safe in that sense. If you want a different value, you need to create a different variable with the same parameters, but it should be a different variable for that. And with that, I think I'm passing back to you, Matthew, to the largest model here.
Yes, this is me presenting, isn't it? Excellent. So what we've got here is we're looking at the floor price to understand where this is coming from. And so for this, we're actually pulling this directly from OpenSea. So do you want me to share?
I mean, it would be, I can show. So this is the floor price.
Perfect. So for this floor price, what we're actually doing, we're actually then combining multiple sources into Machinations here. So the first one being floor. So if you open up that live market feeds at the bottom, what we have here is we've got a variable called floor. We're pulling this from OpenSea. We've selected the project, which is Mini Combat, and we've picked the stat available from this as the floor price for the project. And as we update this, it's updating it in real time, and it's pulling the value in Ethereum of this project's floor price. Obviously, we know that it's going to be 0.0002, but we want to know what that is in dollars. So what we're also doing is we're pulling in that Ethereum price, as Cesar just showed you, and then using a maths custom variable to combine those two into one. So here I'm using the formula ETH multiplied by floor to give me that value of the project in dollars. In the model here at the top, I've got a source that's coming in that's creating that floor price for me, and I'm taking that and I'm multiplying it by 100. So I'm looking at it in cents rather than in dollars, give myself those decimal points. And then we've got some logic here that's randomly kind of increasing or decreasing the price based off of sales. So as part of this, we then want to track, okay, well, what's our commission that we're going to be getting? So how much revenue are we going to be making down on the right-hand side there? But just to show you that you can combine multiple custom variables inside another custom variable and then use that inside your model. Really powerful way of kind of simplifying or making it even easier to use multiple data sources and combine them to get the data that you want. So I think this has been a great session. Thank you very much. We're just over time, which is fine. Please do, let's carry on the conversation though. Obviously we're at machinations.io. Come and follow us on Twitter, machinations.io, our YouTube channel, machinations.io, and obviously our Discord as well, and continue the conversation. If you have any questions or anything you'd like to ask us, Discord is a great place to come and speak to us. So thank you very much, everybody, and please do enjoy the rest of your day.